From the last video, we were able to identify this function a as either this expression or this expression, which would represent this area here. And we have also identified that this function is actually a quadratic function due to that its highest exponent is now 2. Now, in the mathematical sense, the domain of a quadratic function would also be the set of all real numbers. However, if we're going to base it on the situation, we learned that based on the perimeter, which is actually 100, we shall only have 100 as the perimeter will be composed of 1x and 2y's. So this subtly implies that x and y cannot be more than 100, or they should be less than 100. At the same time, of course, they should be more than 0, or technically they can still be 0, but that means no fencing exists. But since we were able to express y as 100 minus x over 2, we can remove that one. So, I could say that my x could be at least, well, technically also it can be exactly 100, but that would give only a length without this one already. If x is 100, that is what would happen. No y here. So, technically, I could have 0 up until 100 as my values of x. Because if I will have a value of x more than 100, then this will become negative. But there is no negative measurement. So, therefore, the domain for the situation would be the set of all x, such that x should be bigger than or at least equal to 0 or less than or equal to 100. Now, please do take note that we keep on identifying the domain not just based on its equation, but based on the situation, because we know that there are even some values that cannot be really in the situation, such as this one, even though the domain allows it to be. So that's why we have to identify that one. Let's have now the third example. You rode a jeepney to go to school, which is 14 kilometers away from your house. The fare rate is 9 pesos for the first 4 kilometers and an additional of 1 peso and 50 cents for every kilometer or fraction of it thereafter. Express the fare f as a function of the number of kilometers x to find out how much fare you need to go to school. So, pause the video and try to analyze what function we can derive here. So, this is what we know. We know that from house to school, it's 14 kilometers. Now, according to this, from the first, we forgot that we're riding a jeepney, and I guess it's only from house to school using a jeepney only. Now, from your house, the fare rate is 9 for the first 4 kilometers. So for kilometer 1, 2, 3, and 4, all of them are the same, 9 pesos. So kilometer 1, let's draw an arrow there, 2, 3, 4. However, after kilometer 4, once it becomes 4 point something and kilometer 5 as well, there is now an additional 1.50, which is actually 10.50. So I can assign 5 there. And even the fractions between 4 and 5. And if I want 6 and the fractions in between 5 and 6, that will be plus another 150, and that will become 12 pesos already. So, how do we now represent this? The first part of our situation is just pertaining to 9, while the next part of our situation has a plus 150. Can we have a formula for this? Well, we can have, but not just one formula. Because in our domain, the plus 1 peso 50 cents rather, does not exist there. So we cannot place that in that part of the situation. However, in our previous situation, such as this one here, this works for any value of x. Even though we restricted the values of x from the original domain, but still the domain for the situation, will work for all of this one. However, in this situation, some parts of the domain behaves differently, some parts of the domain behaves differently. This is where we shall have a function that has more than one formula. And that function is known as the piecewise function, or sometimes rather a piecewise defined function. So a piecewise function is a function in which more than one formula is used to define the output. Each formula has its own domain, and the domain of this function is the union of t smaller domains. We notate this idea like this one. F of x equals, then we write an open brace, we have the formula 1 and its domain, formula 2 and its domain, formula 3 and its domain, and so on if we have more. The first piecewise function that you might have encountered already is the absolute value. The absolute value is defined piecewise. And how does it work? Say for example, we want to find the absolute value of negative 8. So, if we're checking this one here, if x is greater than 0, then we retain the value of x. But if it's negative x, if x is less than 0, then it becomes negative x. Since our negative 8 is less than 0, that means we shall take this value, which is the negative of negative 8. Therefore, positive 8. Hence, the absolute value of negative 8 is positive 8 based on the definition of the piecewise function. So, we can write the absolute value as a function as f of x equals, maybe we can write it here. The absolute value function, if we're going to write it as a function, would be x if x is greater than 0, negative x if x is less than 0. So that's one way of we can write the absolute value as a function. So, can we also write example number 3 as a piecewise function? Piecewise function. Let's look at that in the next video.